Okay, so we've talked about taking a solid figure and determining how many faces the figure has. So this particular prism has a face on the top, has a face on the side, has a face here, has a face here, it's got a face back here, we've got underneath here. So there's actually 6 different faces for this rectangular prism. Okay, we've got different other shapes that we can have. We're going to be calculating surface area today. Now what surface area is taking each one of the faces in a solid figure and finding the area of each individual face and then adding them together to get the surface area. So it's kind of like if I were going to put paper on the outside of this box, how much paper would I need? That would be its surface area. Or if I was going to paint this box, how much paint would I need? Okay, so surface area is the sum of the areas of the faces of a figure. To find the surface area, determine the shapes of the faces and calculate their two-dimensional areas. Then add the areas of all the faces. If you go back to chapter 9, where we found the area of a variety of shapes, we found the area of triangles, we found the area of parallelograms, we found the area of kites, we found the area of trapezoids, we found the areas of circles, and then we found the areas of regular polygons. So we know the formulas for calculating the areas. And so what you need to do is you need to take a solid figure and you need to break it down into its faces. So for example, this is a pentagonal prism. It's called pentagonal because the base of it is a pentagon. Now, how many of those pentagons will the faces of that figure be pentagons? The bottom of it that it sits on and the top of it are both going to be pentagons, right? So there's going to be 2 of those pentagons. Okay, here you can see that the surface area equals 2 of the pentagons that you see. Pentagon is at the bottom that the figure sits in and the top. And then you've got these faces along the side, and here's the face. The face is the shape of a rectangle. And there's going to be 1, 2, 3, 4, 5 of those rectangular faces. So that particular pentagonal prism has 7 total faces. 2 of them are in their shape of a pentagon, and 5 of them are in the shape of a rectangle. And so we have to find the individual area of each one of these faces, and then we're going to add them all together to find the surface area. Okay, so if you will recall, to find the area of a pentagon, a regular pentagon, we're going to use that formula from chapter 9, and I say area equals 1/2 times S times A times N, 1/2 san. Now here they interchange the A and the S, don't worry about that. Doesn't matter what order you multiply in, so I'm just going to keep calling it 1/2 san. Okay, with this pentagon, 1/2 times the side, S is for the side length, that's 10 centimeters. A is for the apothem, that's 7 centimeters. And N is for the number of sides. Well, in a pentagon, we have 5 sides. So I'm going to plug those values in, and I'm going to do the math. 1/2 of 10 is 5. 5 times 7 is 35. 35 times 5, we get 175 centimeters squared. Okay, now that was for one of the pentagons. And how many pentagons did we say there were? There was one on the bottom of the figure, and there was one on the top. Or there was 2. So I would be taking 2 times that 175. They're both going to have the same area, so I don't have to recalculate the 2 pentagons. They're going to be the same. And then to the area of one face. Here's a face. They're all going to be the same. Okay, one of those faces, the area of a rectangle, is just base times height. So the base of this is 14, and the height of this would be, the base of this is 10, the height of this is 14. So 10 times 14 is 140, okay, and then there were 5 of those faces, so I do 5 times 140. Okay, so on your calculator, you're going to want to take 2 times 175, that's 350, and if you take 5 times 140, that's 700, and you add them together, we have a grand total of 1,050, and it's a surface area, so it's going to be centimeters squared. It's a type of area, so it's a squared unit. But all 7 of those faces added up is 1,050. Okay, that's how you find surface area. Let's look at a different shape. What about a cylinder? Okay, if I were to take a pop can, see if I've got a pop can. I don't have one over there. But if I were to take a pop can, you think about it, what's the shape of the top of the pop can? Well, it's a circle. What's the shape of the bottom of the pop can? Well, it's a circle. They're going to be the same circles. So you can see in a cylinder, we've got a circle on the top, and you're going to have the same circle on the bottom. So if I were to pull this can apart, you would see that there was a circle on the top, you got a circle on the bottom, and then if I were to cut this along the side and take that lateral surface and just lay it out flat, what shape would it be in? Okay, you're right, it would be in the shape of a rectangle. So when you find the surface area of a cylinder, you're going to have two circles, the top and the bottom of the cylinder, and you're going to have one rectangle, and that's if you took that lateral surface and laid it out flat. Okay, so let's calculate the circles first of this picture. Okay, to find the area of a circle, we use pi times radius squared. Okay, so pi times, in this case, the radius is 9, squared is going to equal 81 pi. Okay, now that's for each one, and there's going to be two of them. So we're going to end up taking 2 times 81 pi plus, now that takes care of these two circles. Now we've got to figure out the area of the rectangle. To find the area of a rectangle, we use base times height. Now the height of it, 11, we have in the picture. Okay, but we don't know the base of this. That's not ever given to us. But if you think about that, if you take that rectangle and you turn it back into that can or that cylinder, what is this distance covering? Okay, that distance is actually covering the outside of the circle. And what was the outside of that circle called? That was called the circumference. So this distance, this base of my rectangle is going to be the same as the circumference of the circle. So circumference is equal to pi times diameter. So that's where the base here, they put in pi times diameter. So if I take pi times, what would be the diameter of the circle? If the radius is 9, the diameter is 18. So if you take 18 pi times 11, you get this 198 pi. So we're going to add this in. 2 times 81 would be 162 pi plus 198 pi. Now, can I add those two terms together? Yeah, they both have pi. So we can add those two things together. We would get 10, 1, 18, 380 pi. And its surface area, so it would be centimeters squared. My final total would be 380 pi centimeters squared. Oh, it looks like I must have 10, oh, I added wrong. It's not 380, it's 360. I think I multiplied wrong here. 162 and 198, 360. Sorry about that. I don't have anybody here to catch me when I'm wrong. All right, cones. Okay, when it comes to a cone, we've got a little bit of a difference here. So a cone has how many circles? It doesn't, unlike a cylinder that has the circle at the top and the circle at the bottom, the cone just has one circle. So we're going to have a circle, and then that lateral surface. If I were to take that cone and cut it down and try to lay it out, I wouldn't have a nice rectangle like I did with the cylinder. I'd actually have kind of an odd shape. So we have a special formula for that. The lateral surface here of a cone, we use pi times radius times L, and L is the slant height. Okay, so I'm just going to do plus lateral surface. Okay, and that lateral surface is pi times radius times L, and L is that slant height of 16. Okay, so to find the area of the circle, we do the same thing that we did before. Looks like my diameter is 12. That means my radius is going to be 6. So the area of the circle is pi times radius squared plus pi times the radius is still 6 times the lateral height is 16. 6 squared would be 36 pi, plus 6 times 16 would be the 96 pi, and we can add those two together and we get 132 pi. Okay, so we got a lot of different shapes, and it's all a little bit different depending on the shape of the surfaces, the faces, depending on the prism that we're working with, or the cylinder that we're working with, or even the pyramid that we're working with. It's going to depend on the shape of the faces, but the concept is the same. You want to take each individual face of the figure that you're trying to find the surface area to, and you want to combine those surface areas, those areas of each face, okay, to get your total surface area. All right, this is a little bit of work, but give it a shot and see what you can do.